Alright, so I'm Dominic, and I'm going to be talking about facial recognition a little bit. In Ramachandra's 8th chapter of his book, we looked at some of the issues that can go down with some of his patients' facial recognition pathways. And rather than talk about some of those issues, specifically I wanted to talk about facial recognition in and of itself and how it occurs. So basically, we're starting with what we already sort of know. Visual stimulus gets put in through the retina, through the optic nerve, to our primary visual cortex, and from there, basically, different information is sent to different places in the brain. And what I wanted to emphasize is that items and objects get stored in a different place than faces do. And what kind of more recent research has been looking at is that that faces go to a special place somewhere in the temporal lobe or the temporal regions. So I wanted to look at the regions that they're associated with so far, and it's called the inferotemporal lobe, so it's the under part kind of right here of your temporal lobe, and they're speculating so far that it's on the right middle side, and they're actually calling the heaviest associated place the fusiform gyrus, or otherwise abbreviated as the FFG. And one study I found from Stanford, conducted by Joseph Parvizi in 2012, he was helping a man who was experiencing epileptic seizures. He had been experiencing them since he was about 11 years old, and by around 2011 or 2010, his medication wasn't working anymore. So he was in there being helped and treated for that. And actually, one of the things that they ended up doing was that they took a net of electrodes, and they had them. Joseph ended up placing them on different cortical regions of his brain and then simulating them when he was trying to figure out kind of where some of the issues that were occurring were. And he stimulated this fusiform gyrus, and what they figured out is that with this click of a button and the stimulation, they could take away the ability for his patient to be able to recognize faces. And they got it in real time. There's a video that I'm not actually going to share, but it just shows his reaction basically, and when they click this button, he talks about how the doctor's faces morph a little bit. And so this just kind of provided a little bit more insight into the areas that are definitely associated with it. So they know that this fusiform is responsible for it, and they're looking now they divided into two separate parts. The two separate electrodes were on in that study, and that's the mid and posterior fusiforms. There's still speculation on what the two separate parts do, but they do know that it's separated. But basically, from the fusiform gyrus, it passes information to the amygdala, and that's where emotion and different informational pairing is done. Like I said, it's not completely understood so far, but that is some of the more recent research. I wanted to emphasize that there's a lot of different regions associated with facial recognition, and it's not just one or even a couple. But I think in this definition that we're talking about of facial recognition, especially for the book, it's more of this facial identification, and that's why I wanted to focus on the fusiform gyrus, and that's definitely identifying faces rather than, I guess, the emotion inside of them or pairing them with an emotion in yourself as a different mechanism. But also one other thing I want to talk about is when that fusiform gyrus is heavily affected or even debilitated, there's a disorder called prosopagnosia, which is also referred to as face blindness. And when that FFG is basically can be destroyed or messed up in strokes or something like that, they lose the ability to put faces together. So they can only identify people with bigger features like hats or something like that. But rather than talk about more of the disorders, there's a couple more that are coming up in the book. These are my references. And yeah, thank you very much.